when I go with atomic size, right? So the first trend, as we know, is atomic size. So in atomic size, what questions are there? Let me put one listen for this square box and start. So basically in chemistry, what is the smallest atomic size element? So let us write smallest. I'm giving you a question based on atomic size. Smallest atomic size element. What is the smallest atomic size element? That is nothing but hydrogen. Let us put in circle. Suppose if I have to take the opposite of this, what is that? Largest atomic size element. Largest atomic size element. So what is the largest atomic size element? It is nothing but cesium over smallest and largest. It is easy to remember like this, isn't it? Let us write smallest, largest, like that. Next, after this, again the concept of smallest. If I have to take the next one, that is the smallest cation, right? I am writing the same thing here. So if I have to know what is the smallest cation in inorganic chemistry, smallest cation is H plus. Done, students? Now I have to write the largest anion. So when I have to write cation anion, it's a negative charge and positive charge. So cation positive charge, anion negative charge always. So the largest anion or anionic size, it's an anionic size or an anion is iodine minus. So the largest one is iodine minus. The smallest cation is H plus. Done. Let us come back to the next trend. After atomic size, let us go with electronegativity now. Right, let us start. Let me move the page a bit forward. Yeah, I'll put that electronegativity in the next column. So we very well know electronegativity, the ability to pull or drag the electron from the outermost valence electron, isn't it? Valence shell, rather. Pull out the electron from the outermost shell. So in electronegativity, again, two things we have. Let us write highest on that side. Let us write lowest on this side. So if I have to write the element with lowest electronegativity in periodic table is cesium. Okay, students. Next, the element with highest electronegativity is what? It's nothing but fluorine. Done. This fluorine further means after fluorine, the next element in the periodic table is oxygen. Correct? So oxygen is the next electronegative element. Done, students. Now let's come back to the next factor, that is electron affinity. So when I have to take electron affinity as the next concept, again I will take the same square box and learn two categories under this. What are this? I said lowest I'll take it on this side, highest I'll be taking on this side. Yes, students. So in the next video I'll be teaching what is electron affinity, what are the trends in the whole of periodic table. So when I take electron affinity on this side, I said we'll be writing the lowest electron affinity element. On this side I'll be writing highest electron affinity element. So when I take lowest electron affinity element, it would be nothing but noble gases. We very well know noble gases have lowest electron affinity. When I have to take the highest electron affinity element, it is nothing but chlorine is the highest electron affinity element. Now now we have atomic size over, electronegativity is over, now electron affinity is over. Let's start to write what do you say after electron negativity? Okay, let me write electropositivity also. Okay, so after electronegativity, electropositivity is the next factor. So in electropositivity, let me put a box. We have written electronegativity in the earlier page here. Now I'm writing electropositivity. Again, as I told you, I'll be writing least on this side. I'll be writing highest on this side. So the element with least electropositivity is fluorine. The element with highest or most electropositivity is cesium. That's done. Yes. Now electronegativity over, electropositivity over, atomic size over, okay, electron affinity over. Let us write the next concept as ionization potential. Yes, right. So when I write ionization potential, let me take IP. Again in IP, I'll be writing both on this side and this. The element with the lowest ionization potential is cesium because the size is big. The element with highest ionization potential is helium because it is an inert gas. Isn't it, student? Now let us write with the next criteria. Let us come back. Now we have seen atomic size, we have seen electronegativity, we have seen electropositivity, we've also seen the trends in electron affinity. Means not the trends, basically the lowest and the maximum, the least to the highest element. Right. Now let's see a trend in melting point and boiling point. Suppose melting point, if I have to take, and if I have to take boiling point. Done. Right. So in melting point, again let us write on this side, left hand side lowest. I like writing on this side. Now melting point, if I have to write highest. So when I take lowest melting point, right, and here lowest melting point and lowest the boiling point non-metal, lowest melting point and lowest boiling point non-metal, right. Next one, highest melting point and highest melting point as well as highest boiling point also. Lowest melting point, lowest boiling point non-metal is what? That's nothing but helium. Let us come back to this. Highest melting point and highest boiling point metal. What is that? It is nothing but mercury. Right. You're liking this, I think. Let's come back with boiling point. The element with or the non-metal with highest. So highest boiling point non-metal, highest boiling point non-metal, highest boiling point. Talking here only about highest boiling point non-metal. That's nothing but your carbon, right? So in that carbon, what is that form? That is nothing but diamond. The diamond form has the highest boiling point and it is a non-metal, because we very well know it's very difficult to break the diamond and boil it because of the strong bonds among them. Yes, students? Yes. Now let's come back to the next category. Let's see which is like if I have to take hydrogen as an element. Now hydrogen is this element. What are the different names given to this? Basically in periodic table, hydrogen is known to be, means among this, it is the lightest element in the periodic table. Means hydrogen, when it is categorized, lightest element of the periodic table. This is also called notorious element, remember. So hydrogen is the lightest element as well as notorious element. When they ask you in the question, both the ways you can answer. Lightest is hydrogen, notorious element also is hydrogen. I think this is getting clear, students, to you all. Now what did we learn? We have learned atomic size, we have learned electronegativity, we have learned electropositivity, we have learned electron affinity, then I've taught you melting point, then I've taught you boiling point, then I have taught you what is the name given to hydrogen. Now let us speak in terms of conductor of electricity. Right. So when I have to write after hydrogen, let me shift my page a bit further up so that it's clear to you all. Yes, students? Right. So now when I speak about conductance or conductor of electricity. So which conducts electricity, which allows the electrons to flow. So when I have to take, right, conductor of electricity, both the sides, the metal which is conductor of electricity is silver. The non-metal which is conductor of electricity, is graphite. Hope this is clear, students. Metal conductor of electricity is silver. Non-metal conductor of electricity is graphite. Right. Let me take one more very important related to this. Poorest conductor of electricity. I should take that also. No, now we said conductor of electricity, and I have to see at the same time poorest conductor of electricity. So poorest conductor of electricity is what? As you know, it is nothing but diamond. Yeah, it has covalent bond formation in that. So covalent bond tightly packed. Hence, poorest conductor of electricity is diamond. This is over. Let me write one more. What is that? Now I'll be writing in terms of density. One more factor or one more concept of periodic elements. We study, right? Physical properties, chemical properties, the different parameters or the different characteristics of periodic table. So density is also one more. So the metal or the element which has density maximum in metals is osmium and iridium, and when I take in terms of non-metals, it is nothing but boron. Done, students? Is it clear? Oh, so nicely we have explained so many. Let's come back and go to the next category. Let me move my page above. Suppose if they ask me question in terms of abundance. Okay, so abundance in earth crust, abundance in universe, like that. So let us write the first category. The gas which is abundant means more in atmosphere. Gas abundant in atmosphere. What is that? It is nothing but nitrogen. Done. Right. Next one. The element abundant in Earth's crust. So let us write element abundant in Earth's crust. What is that? Nothing but oxygen. Done. Next. Element abundant in universe. Earth's crust is over. Now element abundant in Earth's crust is over, isn't it? Now let us write in universe. An element abundant in universe. What is that? It's nothing but hydrogen gas. Hydrogen. Now I'll also teach you what is this rarest element in Earth's crust. I have to learn that also, isn't it? So my charger fell down. Okay, right. So rarest element in Earth's crust. Let us write that. Rarest element in Earth's crust. What is the rarest element in Earth's crust? It's nothing but astatine. AT. So ASTATINE. Astatine. Now next, metal in Earth's crust means the abundant metal in Earth's crust. Abundant metal in Earth's crust. What is that? It is aluminium. Okay. Gas in atmosphere, abundant element in Earth's crust, abundant element in universe, abundant rarest element in Earth's crust. Not abundant, basically rarest element, right? And this is different. Rarest element in Earth's crust, astatine. Metal in Earth's crust, aluminium. I think all the information is there and under this page. Now I'll teach you one more in this. What is that? Basically, what did we learn? Let us recollect once. We have learned, I think, yeah, first one, we have studied about atomic size. Then we have studied about electron negativity. Then electropositivity, electron affinity. Then we have studied about density. We have studied about what is the factor about hydrogen. Then we have studied about, elements like melting point, means the characteristics like melting point, boiling point, isn't it? Yes. Now let's start up with one more concept, that is storage concept. Suppose if I have to store the element which you can store in water, that's nothing but phosphorus. Phosphorus, the element which you have to store in kerosene, that is nothing but 1A group elements. 1A group elements are there, isn't it? Except lithium. Except lithium, remaining all elements I can store in kerosene. Done, students. Now let me start one more concept here. Amphoteric nature. Let us write that. Amphoteric. So abundance we have seen. Now we will see amphoteric. That means which the elements which react with both acid as well as base. Amphoteric in nature. Right. Now let us write here. First one. The amphoteric metal. What are the amphoteric metal we have? Which is beryllium. Zinc is amphoteric metal. Aluminium is amphoteric metal. Tin is amphoteric. Lead is amphoteric. The amphoteric oxide. What are the amphoteric oxides which we have? That is, we have BeO, Al2O3, ZnO, PbO, SnO, SnO2, SbO2O3, Sb2O3, As2O3. All these are amphoteric oxides. Done. Next, what is an amphoteric metal oxide? Example of metal oxide, metalloid, which shows both the characteristics of the metal as well as non-metal. So the amphoteric metalloid which we have in the periodic table is silicon. Remember this, students. Yeah? Yes. Now, what is the next one? What category can I learn? In the periodic table. Okay. Basically, what is the largest element period? what is the smallest period, right? Before that, let me go with the heaviest and lightest. Okay, suppose what is the heaviest natural occurring element? Heaviest naturally occurring element. Heaviest naturally occurring element. What is the heaviest naturally occurring element available? It is nothing but uranium. When I take heaviest, let us take with the lightest. Now this is heaviest, let me take with the lightest. So lightest, same thing, lightest solid metal. Okay, lightest solid metal. So the lightest solid metal which we have here is nothing but lithium. Okay students, done. This is one category. Now I'll slowly go into a category like most abundant. Okay, so we have written more abundant, now we will write most abundant. So when I take most abundant, means I'm talking about periodic table now. So in a periodic table, most abundant in periodic table, in S block, D block, like that we will write. So in periodic table, most abundant D block element is what? In P block or S block. So let us say S block. In S block, what is the most abundant element? I'll also teach you which is the most abundant gas in nature. Gas in atmosphere. So in S block, the most abundant element available is calcium. In D block, the most available element is iron. And the gas in atmosphere, the gas which is present abundant in atmosphere is nothing but nitrogen gas. Right students? Yes. Now let us speak something about the periodic table. In a periodic table, what is the smallest period? Let us write that. The smallest period, guess students, let me be very well know it. The smallest one would be the first period. How many does it have? It has only 2 elements. Correct? That is your hydrogen on this side, helium on that side. What is the largest period which we have? The largest period in the periodic table, that is the 6th period. How many elements are there? 32 elements are there in that. Right. Now let me start with the largest group. I should not say smallest group, isn't it? Nothing. All are equal here. So the largest group is nothing but 3b elements group. How many elements are there? There also 33 elements are there in the largest group. Right. I've studied about so many things today, isn't it? 63 facts I say. Okay, I'm trying to give all the data which I could get or collected from different sources. Right. Now, next thing, after largest, after smallest, after the concept of abundant element, let us start. What is one more concept? Means this is what dry, if they give you, what is that thing? Suppose what if they ask you what is dry bleacher? Means bleaching agent basically. If they ask you what is dry ice? So dry bleacher is nothing but hydrogen peroxide. Dry ice is nothing but solid carbon dioxide. This is done. Right. So dry bleacher is hydrogen peroxide and dry ice is solid carbon dioxide. Hope this is clear, students. I'm not confusing you all. Because the concept here like this, if you study like this, it's easy for you. Yes, right. So here in density thing, we have written density earlier. Now let us see the same density if it is highest non-metal or highest metal. So I think in the earlier thing we have done this density concept. But here remember highest non-metal, okay, let me write again, density concept, density. What is the element with highest density, both highest only, highest non-metal, and which is the element which has highest metal? Means it is the same thing, but here I'm writing in terms of non-metal and metal. So the element or the metal which highest density is nothing but osmium and iridium. The metal with highest density is osmium and iridium. Again, the metal with highest, means the non-metal with highest density is nothing but boron. Right students, this is clear. I hope this is clear students. Right, let me add some more to this today. I wanted all the information to reach to all my students, so I'm writing some more facts. What are they? So what are the noble metals which we have? What are the volatile metals in D block? What is a poisonous element? What is this one, liquid non-metal? What is a lightest element? Like that. Let us note all those things. So if I have to add some more, what are the noble elements, noble metals? It's nothing but gold and platinum. Noble elements everybody know. Zero group elements of group 18, that is helium, neon, argon, krypton and xenon. But here there was noble elements. Now let me write one more category. What are the volatile metals which we have in the periodic table? The two in D block. What are they? Zinc, cadmium, mercury, UNB. We write it as UNB by M. By means 2 students, 112 element, 112 element. Next, what is a poisonous element which we have? Poisonous element which we have, that's nothing but plutonium. So this also plutonium. Remember the students. Which is a non-metal which is liquid in state? So let us write that, liquid non-metal. So what is liquid non-metal? It's nothing but bromine. I'm sorry, not bromium, bromine. Next, the lightest element, as we know, it's nothing but hydrogen. I think I've mentioned it earlier. I'm writing it again. The lightest metal is nothing but hydrogen. They ask you what is the lightest metal, you should confidently say hydrogen is the lightest metal, because small things we think these are very small but nothing to remember. We have to, because such questions only will make us get close to the wherever you go. Right. Next one, let us write what is the strongest base which we have. So in inorganic chemistry, the strongest base is cesium hydroxide. Now, strongest basic oxide. What is the strongest basic oxide? We will see. The strongest basic oxide is CS2O. Same thing. One more. Which is a stable carbonate which we have? Stable carbonate. Let us write stable carbonate. So the stable carbonate is cesium carbonate. Right. The element with highest oxidation state in the periodic table, highest oxidation state is osmium. What is the oxidation state of osmium? It is +8. Remember that +8 is the oxidation state of osmium. Right, students? Yes, I think almost I've covered all the listen. If anything is missed out, let us come back. Something is missed out. Let me cover that also. Right. So group with maximum gaseous elements. Let us write that. Group with, I took 63 facts. So let me cover that. Group with maximum gaseous elements. So which is the group which has maximum gaseous elements? In that they're asking. So the group is the last group, that is group 18 elements. So in group 18 is a group which we have maximum elements. That is group 18. What do you call it? It is nothing but zero group. Helium, neon, argon, krypton and xenon. Right. Next, what are the total number of gaseous elements in periodic table? Total number of gaseous elements in periodic table. Gaseous elements in periodic table. Basically 11 gaseous elements are there. What are they? Hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton and xenon. Right, students? Yes. Right. Next important thing. Okay, how many did I write? 3, 6, 9, 10. Okay, 10. I'm sorry. Next, students. Which are the total number of liquid elements? Okay, let me write that. Total number of elements which are in liquid state, liquid elements. So basically, if I have to write, there are 6. What are they? Gallium, cesium, francium, barium, mercury and UNB. Atomic number element 112 in the periodic table. Right, students? Now, one more let us add to our book. What is that? An element means an element which is liquid and it is radioactive. Okay. let us write liquid element. I should not write like this, but I'm just for your clear understanding. Liquid element which is radioactive. So it is francium. Confidently you can say francium. Next, how many total radioactive elements we have in the periodic table? Basically 25 radioactive elements are there. Total number of radioactive elements. How many? 25 are there. So now, what is a volatile D block element in this? Okay, we said there are liquids. So what is a volatile D block element which we have? Let us write that. So volatile D block element. So volatile D block element which we have is zinc, cadmium, mercury. Okay, done. So with the students, I think I've covered almost all the concepts of inorganic chemistry. I have made almost 4 to 5 pages. Thank you for watching, students. With this, I've covered 63 important facts of inorganic chemistry. So in my next video, very interesting video, it will be little bit time. Watch this video completely. In that, I'll be teaching you different trends in periodic table. After that, according to your request, I'll be doing the structures in periodic table. Understood, students? So signing off here with the important facts of inorganic chemistry in the periodic table. 63 facts, important 63 facts in periodic table, or 63 facts of inorganic chemistry. Lot of time it took for me to collect, but thank you so much for watching, students. Practice all these things. I'll meet you again in the next video with the trends in a different way, in a different sequence. You'll understand, you'll love the concept basically. Thank you. Good night. Bye-bye.
Good evening, students. All right. Welcome to one more session of your WOC. This is your Vani ma'am back again with the important video. So what are we going to learn this time? So P block, you all know, students, 10 marks is the weightage for term 1 examination. All right. Yes. So what did I do? I have done or very carefully sat and I have prepared trends with complete P block 15, 16, 17 and 18. Take the trend, give the reason. Take the trend and give the reason. So please watch the video completely, note it with your hand, take a notebook and practice it. So these all will come in the MCQs. Let's see, students. So when I go to group 15 trends, the important one is melting point. So I have written the order with the reason also why phosphine is having less. Reason also I've written. Why ammonia is having maximum, that also I have written. Reason is what? All right. And then slowly I took it to the boiling point. Same, I have written the trend and I have written the reason for both. Slowly then I took into the bond length. Bond length trend also is mentioned here, and along with that I have written the reason also. What is the reason why ammonia has 3 bond pairs and 1 lone pair? What is happening to the repulsions? Why is the size increasing? Why the bond length? Everything I have mentioned here in this particular slide. After this, I slowly took into a concept called bond energy. All right, right, students. Bond energy, bond dissociation, enthalpy. What happens? On what does that depend upon? What is the role of bond length? I have written the trend and I have written the reason also. Slowly from bond energy, I took you into a concept called bond angle. All right. So bond angle, when I see again the same concept, I have made the trend, I have written the reason for both. Why ammonia bond angle is more compared to your phosphine. Reasons are also mentioned so that you can use it for your MCQs. All right. After that, slowly I took into a concept called reducing power, that is the ability to release the hydrogen atom. I have written why ammonia is less and bismuth hydride is the strongest reducing agent. Both the cases, I have written the reasons, so please note it. All right. And important thing, then I have made 2 different tables, one for the basic nature and one for the stability. Everywhere I have written the reason. Please note it, students. So these are all the important trends of group 15. Next comes group 16. Important concept is acidic character. All right. In acidic character of oxides, what is important? why this is more acidic character, what is the reason, why the bond, because of the bond length, how is it affecting, everything I have mentioned here. Slowly I have come to a trend, that is thermal stability. Order also is mentioned here, reason also is mentioned here. Yes, so please note it, students, very important, thermal stability on what happens when I go down the group. Then slowly I took a concept called reducing character and reducing property of oxides. So what happens whether it's easy to lose the hydrogen atom? What is the reason I have mentioned here? Same is with the oxides. So you should remember, based on the inert pair effect, how is it releasing the particular. So everything I have explained along with the reason, note it. Then comes boiling point trends based on hydrogen bonding. Then comes volatility factor, that also I have mentioned here. And slowly I took you into the next concept called bond angle. Why is the bond angle of water more than H2TE or H2S? Reasons I have mentioned on both the sides. Now slowly let's go into the trends of group 17. All right. So group 17, melting and boiling point. Why fluorine melting point is less compared to iodine? Reasons are mentioned here, both the cases. Slowly, I took you into the next property, that is ionization potential, electronegativity, oxidizing power. What is the reason when all the trends are in the same thing? All right. Reasons are also mentioned here. Very important. Please note it. Everything is clearly explained line by line here. I took the trend of acidic strength. Observe carefully, students. Acidic strength. Order is mentioned. Reason is mentioned. Carefully, I have written. So, same thing you can remember for your MCQs. So, how is the proton released? Then comes one more with oxo acids, acidic strength. This also is mentioned. So this strength also is very important, and how it depends upon the release of proton. Slowly, and then I took it to the reducing character, which is the most important part of your group 17. Hi is the strongest reducing agent, and HF is the strongest oxidizing agent. Noted. All right. Then I came to a concept called bond enthalpy. What is the reason why the bond enthalpy value for chlorine is more than iodine? Done. Bond length also I have taken here. Then I have taken into a concept called thermal stability. Again, which is more stable, which can easily release hydrogen atom. So these are all the trends of P block. Please note it. It took a lot of time from me to do this. Share the video with your friends. Thank you so much. WOC is always with you all. Thank you, students.
So welcome students to a 300 questions concept. Now I'll be doing with almost, I've covered the syllabus of this particular chapter. This is alkali earth metals and alkaline earth metals as well as alkali metals. So now let me combine, like I've procured almost 300 questions which are very important for your examination point of view. This 300 questions will include simple, that is normal ordinary thinking skills. It will include average as well as hot, so the high order thinking skills also. So please grade 11 students also try to concentrate, so that will be revision for you all. So as my board is a bit smaller, I try to pick up from the book only directly. I'll be solving all the questions. I'll try to complete all the 300 questions in 2 or 3 days. Done. Fine. So when I have to speak about the first question, which is related to your alkali metals and alkaline earth metals, that is S block elements. What does this question say? It says, right, one thing you should remember, there'll be certain questions which have options more than 2 correct. There is mostly you have only one option correct, but some other questions where 2 options also will be correct, 3 options may be also correct. So let us see that how to do it. So in this particular question, they've given me ionic carbides undergo hydrolysis and produce hydrocarbons. Which are the correct products formed during hydrolysis, right? What are the correct products? So you should know the reaction, which is the correct product, then combine. Here they've given aluminum carbide gives us acetylene, calcium carbide gives acetylene, Boron carbide gives methane, magnesium carbide gives propine, they said. So you need to know the reaction first. That is the reason I've done the whole syllabus first, so that the reactions are clear for you all, and then this. Now let us solve this. The first one, aluminium carbide gives acetylene. So what is the formula? So aluminium Al4C3, when it combines with, because they undergo hydrolysis, is said H2O, what will you get? Aluminium hydroxide plus the leftover is methane, right? So the first one, aluminium carbide and hydrolysis gives methane, but they've given acetylene, correct? So this is a wrong option. They want us to give the correct product. This is wrong. In the second case, calcium carbide. So let me write the calcium carbide, this one. So when I have to write the calcium carbide product, CaC2, fine. So it's calcium carbide when it combines with water. So what do we get? Again, calcium hydroxide plus, you will get acetylene now, C2H2. So this is correct option. The third one, let us go to boron carbide. It undergoes hydrolysis. Again, this forms okay, this is boron hydride or beryllium. Okay, beryllium carbide also. Let this be beryllium carbide, yes. So this becomes beryllium hydroxide taken twice, plus this becomes CH4, right, if you balance it. So CH4. So methane is right. The last one, magnesium carbide, Mg4C3 plus hydrolysis gives me magnesium hydroxide plus C3H4 propane, right? So now what do they give me? Which is the correct product formed during hydrolysis, they said. Fine. So when I have to speak about correct product, C2H2, acetylene, isn't it? Calcium carbide, acetylene is the correct product. This is one option, right? So I said there may be two options, so two or three options. So calcium carbide giving acetylene, this is correct option. Beryllium carbide with hydrolysis gives methane, this is also correct. Magnesium carbide giving propine, this is also correct. So the options are B, C, D. All the three are right in this case. So there may be some questions where three options are right, but you should be careful with these reactions. You need to memorize these reactions, then only you can apply in this. So let us come back and see the next question. So in the next question, what do they give me? They've given me select the correct statement. Yes. So select the correct statement here. The stability of peroxides and superoxides of alkali metals increases with increase in size. Okay. Right, increase in size of the metal ion due to stabilization of large anions by larger cations through lattice energy effects. They've given a condition where the stability of peroxides, they're speaking in terms of stability of peroxides. Right, the next one, lithium. Okay, whether this is right or not, let us see, because the concept, there may be two or three options also correct, I said. Fine, so this statement is 100% correct. So the first option, A, right. Let me come back. Lithium fluoride is less soluble due to high lattice energy, and CSI is less soluble due to smaller hydration enthalpy. Yes, this is also right option. The next one, sodium hydroxide does not form hydrated salt. And okay, the last one, sodium carbonate is less stable than sodium bicarbonate. This is also right, isn't it? We have already given the reason in hydroxides formation. Sodium carbonate is less stable than sodium bicarbonate. Now what is the select the correct options? All three. Why is this option wrong? Sodium hydroxide does not form hydrated salt. That is, sodium hydroxide, when I have to see, is it a salt? No, sodium hydroxide is a base, isn't it? Right, first of all, it is a base, does not form hydrates, so the concept only is wrong. Fine, so this option is wrong, remaining all are correct. So the correct answers are A, B, D. So I am just giving you a clue. You may have three options also to correct, right? So let us go back to the next question. Here in this particular question, what did they give me? 2-ethyl anthraquinol when oxidized in air produces. Okay, 2-ethyl anthraquinol when oxidized. Let us write the structure first. 2-ethyl anthraquinol means one ring here. This is the second ring. This is the third ring, right? So this one, correct. So in this particular thing, in this way. So this one, bonds here. So this is 2-ethyl anthraquinol. So ethyl group is here, CH2, CH3. 2-ethyl anthra, okay, anthracene, that is quinol, this is it. Quinol means in the second one, all OH groups are present. This is 2-ethyl anthraquinol. Now this is oxidized. When oxidized is it? You are adding oxygen to this. When you are adding oxygen to this, During this process, what happens? The hydrogen is rolled out, right? Addition of oxygen, removal of hydrogen from where? This hydrogen and this hydrogen is removed out, and what do you get? You're going to get 1, 2, 3. Right, the CH2, CH3 is there only, and this is also there. This OH gets oxidized to double bond O and double bond O. Now what is this? This is quinone, 2-ethyl anthraquinone. This is 2-ethyl anthraquinone. All this is quinone, right? Fine. So now what is released? Hydrogen gas is released. Now what do they ask during this process? What else is left along with this? These two means when this process is happening, along with that, when I have to see the leftover product, hydrogen gas means this further combines and forms hydrogen peroxide, right? So the byproduct of this is hydrogen peroxide. This is the correct option. Fine. So this is how you're going to do. Now let us see the next question. In this next question, which of the following is true about nascent oxygen? They asked me. Nascent oxygen, which is right? Which of the following concepts of this one is clear? Right. So most reactive than molecular hydrogen. This is one concept they've given me. Then they've given me it can be produced in situ. Fine. Then they've given me it shows similarity exactly with hydrogen in the reaction. Then reduction reaction. Then third option, A and B, they've given me. Both they've given. Right. So in which of the following statement one is true about nascent hydrogen? So if I have to speak, option A, nascent hydrogen, we very well know it is more reactive than molecular hydrogen. Correct? Right. So the second one, it can be produced in situ. That is a known fact. It can be produced in situ. That is also fine. This is also correct. A and B are correct. Show similarity exactly with hydrogen reduction reaction. Wrong, isn't it? It doesn't show similarity with hydrogen reaction with hydrogen. So the option is first option, A and B. Both are correct. This is how you're going to reason it. Now let us see one more question. Gradually we'll go into the concept now. So now what do they give here? They've given me in alkaline medium which elements can produce hydrogen, right? So what actually is this? A particular metal which reacts with both acid as well as base is called an amphoteric oxide. That means when they speak on both, when they react with acid and base, they're going to release what? Hydrogen. That is what they've given here. They said in alkaline medium which elements produce hydrogen. Whenever you see this concept, which element produce hydrogen, that means they're going to speaking about the reaction of the particular metal with acid as a base. What is that? Which reacts with acid and base? That is nothing but amphoteric metals. Metal oxides, metals. Now, what are amphoteric metals? Remember, zinc is an amphoteric metal, aluminium is an amphoteric metal, tin is an amphoteric metal, lead is an amphoteric, aluminium, okay, written already, aluminum is amphoteric. All these are amphoteric metals. Along with that, even silica also comes under that combination. Here, carbon is not amphoteric, isn't it? So, the combination here is zinc with the other one. So, this is the correct option for this. So, remember the amphoteric metals which will react with both acid and base. If zinc reacts with HCl, it will become zinc chloride. If it reacts with sodium hydroxide, it becomes sodium zincate. So this is the thing. Now let us come back and see the next question. So in this next question, what did they give me? The oxide that gives H2O2 on treatment with dilute acid is, they've given 4 oxides which gives H2O2. So for that you should know the reactions first. Let us write the reaction. I already given this hydrogen peroxide, not done, S block I did. So in this particular thing, let us see. So PbO, first one, reacts with dilute acid means you can pick up HCl. Then what will happen? It will become PbCl2 plus Cl2 and water. First one. Second one, what they want? Oxide that gives hydrogen peroxide. No, hydrogen peroxide is not evolved from here. Let us see with Na2O. Na2O2 it should be, right? Yes. Na2O2 plus HCl. It gives us, what does it give? NaCl plus hydrogen peroxide. Okay, our hydrogen peroxide is there here. The next one, let us see MnO2 plus HCl gives me MnCl2 plus Cl2 plus water. Okay, here also there is no hydrogen peroxide because I need to find where is the hydrogen peroxide form. Let us write the reaction as TiO2 plus HCl gives me TiCl4 plus NO, like water, TiCl4 plus H2O. Correct. So this is also done. Fine. So are we finding any H2O2? H2O2 is observed here in Na2O2. So this is the correct reaction is Na2O2 on treatment with dilute acid gives us hydrogen peroxide. This is the reaction. For that, reactions are very, very important in inorganic chemistry. So let us do the next question. So here in the next question, which of the following statement is not correct? Right? Is not correct, they said. Fine. So, I should say which is not correct. Like sodium, baking soda, that is sodium bicarbonate, is more soluble than sodium carbonate. So let us first see this. It is more soluble than sodium carbonate. Okay. Now, if I have to start reasoning, is it a correct statement or not? Let me see. Here only I am getting doubt. What is this? When I have to speak about sodium bicarbonate, what will happen? Sodium bicarbonate, when it is dissolved in water, what does it do? It's going to dissociate into water and like sodium hydroxide and carbonic acid, right? Sodium hydroxide and carbonic acid, that carbonic acid further breaks up into water and carbon dioxide. Correct, that's this one. But here when I have to speak about sodium carbonate, when you dissociate, it breaks up into sodium hydroxide, water and carbon dioxide, isn't it? Right. So which of the following statement is not correct, they said. So I think first option, let me again come back after I got one clue for the first answer. Next one, sodium hydroxide is caustic soda. Correct answer. Sodium bicarbonate is also used as antacid. Correct answer. Ne2CO3 is used in the manufacture of soap and glass. All three are correct. So the option which is wrong is the first one. Right? Fine. So why did I say sodium carbonate is more soluble? No. First of all, sodium carbonate, as soon as you dissolve it in water, this will break up into sodium hydroxide plus water plus carbon dioxide. Simple, as soon as that. But when it comes to sodium bicarbonate, NaHCO3, when you dissociate into water, this will first break up into H2CO3 plus sodium hydroxide. This H2CO3 further breaks up into water and carbon dioxide, isn't it? Or H plus plus HCO3 minus, isn't it? So this is how. So the correct answer is NaHCO3 is more soluble. No, it is less soluble compared to Na2CO3. So the correct answer is A. The correct option is A. Right, now let us see the next question. Which of the following statement is not correct? Fine. What do they give me? KCl is a substitute for NaCl for patients of high blood pressure. Okay, not correct. I need to take out. Fine. The next one, this is correct, isn't it? KOH is a stronger alkali than sodium hydroxide. Okay, that is also right. KOH is used in the manufacture of soft soaps. That is also right. NaOH is a non-deliquescent white crystalline solid. Okay, this is where is the mistake. NaOH is non-deliquescent. What is deliquescence means? Which absorbs moisture. So it's absolutely wrong, isn't it? Sodium hydroxide pellets, as soon as you leave in at room temperature in your lab, these sodium hydroxide pellets, they start absorbing moisture maybe after a duration of 40 or 45 minutes, and they'll start turning into liquid. So sodium hydroxide is deliquescent. It absorbs moisture, and hence it has to be stored in an airtight container. We will store it in an airtight container so that it will not absorb moisture. So the wrong option, the wrong answer for this is the answer. Sodium hydroxide is non-deliquescent. Instead, it is deliquescent. What is that? We said it absorbs moisture. Right, so let us see the next question. What is the next question? Which of the following statements regarding the oxides of alkali and alkaline earth metals is not correct? Right. So what do they give me? They've given a very big question. Let us read one after the other. What should I do? Which is not correct? I should find which is wrong in this. First of all, the first question: the reactivity of K2O towards water is more than Na2O towards water. Okay, right. When I told you the oxides, the first this is an oxide concept also. I've told you the same. So the reactivity of K2O towards water is more than that of Na2O. Yes, that is obviously that 100% right. Next one, the oxides of alkaline earth metals are more basic than those of alkali metals. This is wrong, isn't it? Why is this wrong? Because the oxides of alkali metals are basic. I accept that, but they're less basic than alkaline earth metals. Right. So why? What is this? Because what should you speak in terms of? Because alkaline earth metals are less electropositive. isn't it? So here they're more basic they've given, but my justification is they're less basic. Why they are less basic? What is the concept? They are less electropositive. What is less electropositive? Means the ability to donate that pair of electrons or donate that OH minus ions, correct? So why? Because the size is smaller. When I go from left to right in the periodic table, the size becomes smaller. When the size becomes smaller, it's very difficult for me to release that OH minus ion. So alkaline earth metals are less electropositive. That means less basic. Less electropositive means less basic. So now what is this concept now? Come back. The oxides of alkaline earth metals are more basic or less basic? No, less basic. So this is the correct option. Means the answer should be, this is wrong statement. The answer is B. Let us see this also. MgO is used as a refractory material for lining electrical furnace. This is right again. The next one, the milk of lime and lime water is two different solutions. Basically, when I already told you in last video, that is your calcium hydroxide, when it is in the form of a suspension, then I call it as milk of lime. When it is as a clear solution, I call it as lime water. So both are the same, but only the physical state is different. So the answer is, this is the wrong statement. This is the justification, right? So let us come back and see the next question. Very interesting, isn't it? So what is this? Which of the following statement is not correct? Again, not correct statement only. They are asking us to find the different reasons for each, right? So let's see. KOH is a stronger base than sodium hydroxide, which is not correct. Okay, let us see this. Whether is less strong than sodium hydroxide, it seems. This is wrong, isn't it? Why is this wrong? First only I got the answer. Why is this wrong? Basically, let us justify. KOH is stronger than NaOH. That is the first important concept you know. They said less strong alkali. It's stronger than NaOH. Why? As its solubility, that particular solubility thing is based on their, like, we speak in terms of the molar basis. We speak the term, or we speak the concept in terms of molar basis. When we speak in terms of the solubility in the molar basis, KOH is stronger than NaOH. That is the main thing. So what do they say? The first, which is not correct. So the first answer is correct. Let us see. Milk of magnesia is an aqueous solution of magnesium hydroxide. That is right. Mg+2 ions are not precipitated with addition of ammonium hydroxide in the presence of ammonium chloride. Well, this is also right. Next, calcium oxide is less stable than magnesium. It's an MgO2. Yes, this is also right. So the wrong option is this, because KOH is stronger than sodium hydroxide. You need to see the options and remember the concept. Yes, let us go to the next question. What do they give me? When chlorine is passed through moist slake lime, right, the compound formed is moist. Okay, chlorine is passed to moist slake lime. Slake lime is nothing but calcium hydroxide, isn't it? Fine. So what is the product form? Let us write the reaction now immediately. Moist slake lime, that means calcium hydroxide plus chlorine. What do we get? We are going to get a product that is CaCl2 plus, I'm not balanced, right? Now we've already seen this reaction, isn't it? Now calcium chloride, what happens here when it combines calcium hydroxide, when it combines with chlorine, it's going to form calcium chloride, that is calcium oxychloride, that is bleaching powder plus water. So the correct option for this is CaOCl2, right? So this is the right one. Let us see the next question. Here in this question, what do they give us? The solubility of hydroxides of alkaline earth metal increases down the group. Fine. So first of all, when such question is given to you, you should remember only one concept. What is that concept? Solubility. If they give you, what did I say? I said if hydration enthalpy is greater than lattice enthalpy, the particular salt is soluble. If the hydration enthalpy is less than lattice enthalpy, the salt is insoluble. Remember this. Fine. Let's come back and see. What is it? The solubility of hydroxides and alkaline earth metal increases down the group. Fine. So it increases down the group. That means I need to reason this according to this. What do they say? The decrease in lattice enthalpy is more. Solubility of hydroxide is increases. That means when it is increasing, that means it is soluble in nature. When does it soluble? When the lattice enthalpy should be lesser. So in the first case only I got the answer, isn't it? The decrease in lattice enthalpy is more than in decrease in hydration enthalpy. The first answer only is this, because this is, I'm trying to satisfy this option with this. So the correct answer for this particular concept is A. Fine. So next, come back. Next question. What do they give me? A compound which can be used in space vehicles. Fine. So which can be used in space vehicles both to absorb carbon dioxide and as well as to liberate oxygen is a compound which can be used in space vehicles for carbon dioxide and this one. So what is this option to absorb carbon dioxide liberate? They've given us sodium hydroxide, then they've given us Na2O, then they've given us calcium oxide, then they've given us sodium hydroxide. So what is that used in the vehicle? Fine. So next, if I have to speak such in terms of such questions basically are direct questions, isn't it? So you need to just have the information about this question. So if I have to speak about the answer for this, what is this? So for such questions, the correct answer is Na2O2. So this is the correct option. Direct answer. There's nothing. Remember. So it can be used in space vehicles. If they speak about submarines, try to KO2. If they give you space vehicles, the correct option is Na2O2. Fine. So let us see the next question. What do you give me? Which will give N2O on heating? Okay, again reactions. So let us do this. N2O. So which of the following compounds on heating should give N2O? So let us write that question. What is that? Ammonium nitrate, NO2, on heating gives me nitrogen gas plus 2 water molecules. Correct. Ammonium nitrate. This is over. And next one. NH4, NO3. On heating, what will happen? It gives N2O plus water, gaseous state. Ruled out. Okay, I've already got the answer, isn't it? N2O I've already got. Next, NaNO3. Let us see. NaNO3 on heating gives me NaNO2 gas plus oxygen gas. If I have to speak about LiNO2, so this becomes LiNO2 breaks up on heating into Li2O plus NO2 plus oxygen. So the correct option is ammonium nitrate on heating gives me N2O. This is the correct option according to the equations. Yes, so right. So let us see the next question. What is the next question? Choose the correct statement. Fine. So they gave me beryllium carbonate is kept in atmosphere of carbon dioxide since it is least thermally stable. Fine. Correct statement, according to me, yes, this is right. Beryllium fluoride forms complex with NaF in which beryllium goes with anion. Okay, beryllium dissolves in alkali forming beryllium BeOH taken 4. Okay, that is also right. Which is, choose the correct. That is one, that complex. Okay, I should say fine. That is not appropriate. Then BeF2 forms complexes with NaF in which B goes with cation. Okay, so now according to the analysis, let me see. Correct statement I need to find. First one, if I go into the depth of the topic, that is wrong basically. Second one, BeF2 forms complexes, that is also wrong. Third one, salt forms dissolves in alkali forming that coordinate complex, that is also wrong. What is the correct statement? The correct statement, if I have to speak, the correct answer is Na2, because it's going to form a complex with this. Fine. So I need to put the correct statement. So I need to remember the concept. Okay, let me see this if I can justify. What is this particular one? BeF2. Okay, let me see. Beryllium F2 combines with NaF. Fine. What is that? It's going to form a complex, that is Na2. If I take 2 moles of this, Na2 BeF4. Okay, so here they said BeF2 forms complexes with NaF in which beryllium goes with cation, but beryllium is going with anion, right? So my whole analysis is really wrong. What is that? Beryllium is going with anion, so this is a wrong option. Beryllium, this is correct, this is correct, this is also correct, right? So the answer is A, B, C, all 3 are correct. So this is how it forms. It does not go with the cation, it goes with the anion. This is where you need to be careful. Yes. Next question. Setting of plastic of Paris. Setting of plaster of Paris or plastic of Paris. Setting of plaster of Paris, we've said. This is plaster of Paris, is it? What is that? So basically, when I have to speak plaster of Paris, only one reaction which I've already taught you. CaSO4 dot 2H2O, so half H2O hemihydrate by 3/2 H2O gives us CaSO4 dot 2H2O. This is gypsum, isn't it? Yes, that is plaster of Paris. This is gypsum. Simple. So here what are they asking? They're asking setting of plaster of Paris, right? Is it oxidation? No. Combination with atmospheric carbon dioxide? No. Dehydration? No. It is hydration leading to another hydrate, right? So it is a hydration, addition of water to form another hydrate. So the correct option is D. That's it, isn't it? Simple. Next question. What do they give me here? Which of the following, which is the most stable halide of alkali metals? So basically, whenever they ask you about the stability, what concept should you remember? Just simple. Stability of the particular thing. Speak in terms of delta H formation, standard delta H formation. This formation of delta H, the standard enthalpy of formation. So standard enthalpy of formation you need to speak. Now what is this? If delta H value is more negative, okay, let me write. If the delta H value is more negative, then the particular halide is stable. If there is stable, remember this. So now when I have to speak about the delta H value for NAF, how much is that? 569. Here for this NABR it is minus 360, NaCl is minus 411, here it is minus 258. Now I said more is the negative value of delta H, more is its stability. So among all, NAF has a maximum value. That's why this is the most stable halide. So this is your concept. Remember this. Fine. Yes. So next one. Next question. Which ion is paramagnetic? They said. Okay. So when they give you paramagnetic concept, remember what is this? Paramagnetic is nothing but number of unpaired electrons, isn't it? So number of unpaired electrons. How do you take this? Just simple. I'll tell you. Calculate. Let me take KO2. So KO2. How much is this? The atomic number 19. One oxygen is 8, one more oxygen is 8. Together 35. 35 means it is nothing but odd number, isn't it? So when it is odd number, that means it is paramagnetic in nature. Paramagnetic. Next one, if I have to calculate K2O2, if I calculate, I get 54 electrons. This even K2O, they get 46 electrons. Okay, NO2, I get 23 electrons. Odd one out. Odd one electron you have, isn't it? So odd one out. But here paramagnetic is, and here there's a small deviation also when you draw the structure because of the resonance. So KO2 is only one which is paramagnetic. Try to calculate the number of electrons, you will get to know. Fine. Next question. What are the which are involved in various physiological functions in animals? So simple, isn't it? You need to have the basic information. Sodium, Na plus, animal function, they said, physiological functions in animals. So Na plus, where is it used? It is used in muscle contraction. So muscle contract, there are many uses, but I'm just writing the basic one, muscle contraction. And I have to speak about K plus. It is used as nerve cell transmitter in animals. Very important function. Nerve cell transmitter in animals. Correct. When I have to speak about magnesium, Mg plus 2. It is used in aircrafts, bulbs, flash, different metal, like that, aircrafts, bulbs. Fine. So this is in nerve cell transmitter in animals. Now Cu plus is used as alloying. It is used in alloying, maintaining fluids also. Alloys, it is used in making alloys. Right. And potassium, one more important thing I forgot to say, it is used to maintain fluids. Potassium maintains fluids and electrolytes. Fluids and balances the electrolytes in the body. So the correct option is potassium, which is used for in the physiological function of animals. Right. Next question. Select the correct statements. CaCO3 is more stable in a solution of carbon dioxide than in water. Okay. Argonite is a metastable form of calcium carbonate occurring naturally. Calcium carbonate cannot be decomposed by heat. Lithium nitrate on heating is LiNO2 and oxygen. Okay, I need to find the correct answer, correct statement basically. Basically, calcium carbonate is more soluble in a solution of carbon dioxide than in water. It's 100% correct option, isn't it? Yes, next. Argonite is a metastable. Okay, what is argonite? Argonite basically is a mineral consisting of calcium carbonate. Fine. So it is a metastable form of calcium carbonate. Yes, it is right. Yes. Now let us see the wrong answers. Calcium carbonate cannot be decomposed by heat. Wrong, isn't it? Why? Because calcium carbonate on heating gives me calcium oxide plus carbon dioxide. Lithium nitrate and sorry, and heating gives, right, nitrogen dioxide, isn't it? Not oxygen. So this also is a wrong statement given. Fine. Like lithium oxide plus nitrogen dioxide. This is also wrong statement. So this is also wrong. This is on the correct option is A and B. This is what is important. Next question. Let us see the next question. So which of the following mixtures cannot be prepared? Fine. Which of the following cannot be prepared, they said. So when I have to speak about this, I'll just directly tell you the answer. The correct answer is this. This cannot be prepared. Why? Because when, let me write the reason. Because Na2CO3, when you like these two, when these two combine, okay, let me write the reaction. NaHCO3 plus NaOH. When they combine, what do they form? They form Na2CO3 plus water. Right. So now the carbonic acid, whatever is there, is still an acid in this case, isn't it? When it's still an acid, what can we do? This bicarbonate, it can lose its proton to give CO3 because it's still an acid. When this dissociates, this becomes H plus and CO3 minus. So it can give H plus proton to give CO3 minus. So CO3 minus is a conjugate base of this, isn't it? That is why this combination is not possible. It cannot be prepared. The reason is, say, CO3 is still an acid, and this one can always lose its proton, isn't it, when it dissociates. So, and it gives carbonate of its particular conjugate base. Done. So let us see one more question. NaOH finds its use in, okay, direct question, which it finds its use in paper industry, it finds its use in soap industry, it finds its use in rayon industry. Right. Direct question. Let us see next question. Na2SO4 is water, is soluble, but barium sulfate is insoluble. The same question repeated. So you should always remember what is the clue in this. Hydration enthalpy should be greater than lattice enthalpy for something to be soluble. So according to this concept, I've already reasoned this question earlier. According to this concept, the correct answer is B, because hydration enthalpy should be greater than lattice enthalpy, then that is soluble. Fine. So that is the answer. Fine. So let me come back and do subjective problems in my next video. Very interesting subjective problems are there. We'll be doing so many questions like that, till 300 questions, many more to add on this. First of all, try to revise the earlier chapters which I taught you, the earlier concepts, and then only come back to this. Then only you will understand them. What is this in this? They will not use all their donor atoms to get coordinated. Means when they are coordinating, they do not use all the donor atoms. Example is EDTA, it acts as hexadentate ligand. But it can also act as pentadentate and tetradentate ligand. That means it will not use all its donor atoms. So example is EDTA. So the difficult part of inorganic chemistry, on daily basis I'll be mentioning or sending you in the form of trick. I'll give you sets and sets of different types of reactions where everything will have a trick. So let us see the first trick for inorganic chemistry, how to memorize the reaction. So let's start. So when I take this compound, what are these? Basically all these are interhalogen compounds, isn't it? So whenever interhalogen compound is given to you, suppose in the question paper, if they ask you so and so interhalogen compound combines with water. So in interhalogen compound, basically we have 4 sets. What are they? AX type, AX3 type, AX5 type and AX7 type. Done. Suppose if I take AX, right? So in this AX, suppose if it is combining with water, what happens? When AX3 combines with water, what happens? When AX5 combines with water, what happens? And AX7 combines with water, what happens? So first let us have one picture of general equation for that, right? So when I take AX type, now what is A? In this, in interhalogen compounds, there is a combination of both two different halogens, right? One would be the larger one would be the smaller one. Larger one, smaller, larger, smaller, right? So in interhalogen compound, one would be the larger one would be the smaller halogen atom. Just see, whenever AX type is given to you, when it is hydrolyzed, you will be getting common thing, that is HAO. Remember, for AX, you will be getting HAO. We'll see what HAO is. Done, right? For AX3, you will be getting HaO2. For AX5, you will be getting HaO3. For AX7, you will be getting HaO4. Simple. Let's start again. For AX, you will be getting HaO. For AX3, you will be getting HaO2. For AX5, you will be getting HaO3. For AX7, you will be getting HaO4. So, 1 O, 2 O's, 3 O's and 4 O's. Done. But the common thing everywhere is HX. HX is common. Every reaction HX is common. Now with this general formula, let us start off writing the reaction. When I take the first interhalogen compound, I have picked up different combinations. So what is in my mind? As soon as I see the interhalogen compound, first thing, take your pen and write like this. What is this atom? This is bigger atom. This is smaller. This is smaller. This is bigger. Isn't it? Now see the combinations. For everything, it's the same. Always combination is a bigger atom. First one, a smaller atom, a bigger atom will combine. Right? Let us see. A smaller atom is first, then bigger, right? Let us see the combination of these. Now, what is the first thing? I said HAO. When AX compound is there, HAO. So, what is H here? H. What is A here? I said bigger atom compared to this. The first one is HI. Next, O. What is left over thing? One more H is here, H. Now I said you still have this chlorine, HCl will come out. So HX is HCl. Done. So smaller, bigger and bigger atom. Let us write here. Now H, bigger atom is Cl. Then comes O. What is left out now? HF is left out. Now in this combination, bigger H. What is the bigger atom in these two? Br. O. What is left out? HF. Easy, isn't it? Right. Now let us come back and see AX3 combination now. So same concept. When AX3 is there, I'll be getting HaO2. Here HAO is a thing. Here HaO2 is a compound form. Same concept again. Take a smaller, bigger. Done. What is a smaller atom here? H. Now what is the bigger atom here? Iodine. What is the next one? O2. What is left out? HCl is left out. Let us see here. Same concept. I have to write H. Bigger atom compared to these two. It is Cl. Right? Then what is this? O2. What is left out? HF. Easy, isn't it? Now let's come back and see the next one. When I take AX5, the compound which I have to get is HaO3. Same concept, right? SBB. Done. What is here? Smaller atom, hydrogen. What is the next one? Bigger atom here, iodine. What is the next combination? Oxygen. How much will be there? 3. Now what is left out here? HF is left out. Let us see the next one. Same concept, SBB. Let's see. Here, start with H. Then, what is a bigger atom here compared to these two? Chlorine. What is the next combination? O3. And what is left out? HF. Now, when I take this, same combination, H here, I have to take the bigger atom here. Bigger atom is bromine. What is oxygen in this form? O3. Plus, what is left out? HF. Next, let us come here. In this combination, what is a smaller atom? H. What is a bigger atom? I. What is the next one? Oxygen, O3. What is the leftover is? HF. Easy, isn't it? Now, right. When we come back and see the last reaction, that is AX7. What did we say? In AX7, the compound formed is HAO4. Let us write. So again, apply the formula SBB. Right. Now, H, a smaller atom is here. H. What is the bigger atom in these two? I. What is this oxygen? 4. What is left out now? HF is left out. Done, isn't it? So this is how we are going to do or learn the trick. Understand, students? It's clear and easy. General formula, trick, and use it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost 10 reactions. We can learn it in 2 or 3 minutes.
Yes. Let's see the first question, students. Whose boiling point is more? Quickly, we are going to write, tick the correct answer. Okay. Whose boiling point is more? Basically, if I have to take, okay, let me take a different pen for you all. so that it's basically it will be clear for you. Let me take a pen. Which pen? Black will do. Okay, chalo, done, students. First question: whose boiling point is more? We very well know due to hydrogen bonding. Tick this answer. Tick. Perfect. Which is more basic? I said in fraction of a second we have to give. Right. Which is more basic between ammonia and bismuth? If they give you ammonia is more basic. Which is thermally more stable? Yes. Stability. H2S is more stable because the size is small. Perfect. Fourth question. Which is more reducing in nature? Okay. H2O or H2S? H2S. Which is more acidic in nature? All rapid fire we are going to do, students. Which is more acidic? Larger the size, easy to release the number of electrons. Perfect. Question right. Ammonia, bismuth or phosphine? Whichever has the lone pair of electrons. When I see ammonia is the answer. Which dissolves more in water? Whichever has hydrogen bonding, ammonia is the answer. Which is the basicity? What is the basicity of H3PO4? 3 is the answer. Which is more reducing? Phosphorus acid, phosphonic acid. So here little change, students. This should be phosphoric. Okay, I'm sorry. This should be phosphoric. RIC. Okay. Which is more reducing? Phosphonic or phosphoric acid? Okay. Onic acid is more reducing. Remember. Which is more acidic in nature? 10th one. HOCl, HClO3. More number of oxygen atoms, more would be the reducing power. Okay. Next question. Which one disproportionates on heating? Which reaction? It shows disproportionation reaction on heating is the answer. H3PO3 or H3PO4? Answer is this. Which has more boiling point? Again, you need to see the hydrogen bonding, water or HF, more electronegative. Which is a better complexing reagent? Both the things. Which will form more complex? Ammonia. Which can act both as oxidizing as well as reducing agent? Yes. Oxidizing reducing agent, sulfur dioxide. What is oleum? Pyrosulfuric acid or pyrophosphoric acid? We know it is pyrosulfuric acid. Next, sulfuric acid is prepared by Ostwald's process or contact process? Contact process. What is the covalency of nitrogen in N2O5? It's 5. Number of atoms surrounding. Which one exists? R3PO exists or R3N? So basically it doesn't have any d orbital, so this exists. Which decolorizes acidified potassium permanganate solution? Moist SO3 or moist SO2? When copper metal is treated with dilute HNO3, what is produced along with copper nitrate and water? The gases. Always remember, students, when you take dilute acid, only one simple concept. You are going to get NO gas. With dilute NO, with concentrated NO2. Got it? Oh, easy. You're getting understanding. Next, students. 21st question. The spontaneous combustion of which gas is technically used in Ohm's signals? Whether phosphine or H2S, PH3. Name the common acid used in pickling of stainless steel, oxidizer in rocket fuels and in explosives. Quick answer, HNO3. Which gas is poisonous and has rotten fish smell? Yes, PH3. Right? So careful, students, don't immediately write hydrogen sulfide. I said poisonous gas. That's why phosphine. Next comes 24th. Which one of the oxides will not have two different nitrogen oxygen bond length? Okay, will not have. So which of these oxides of nitrogen will not have two different? That's nothing but N2O4, because it forms a dimer, isn't it? It's a dimer form, right? Which acid is more acidic? As I said, more number of oxygen atoms you need to see, but here in this case CrO3. The catalyst which is used in contact process are, whether it is platinum, rhodium gauge at 500 Kelvin or a 9 bar or B2O5. So vanadium pentoxide is used in contact process. Which is the anhydride of HNO3? Means if you remove the water molecule, what is the anhydride? So N2O5. Right? Very good. Easy, students? Yes. Which one is colorless gas? Neutral, reactive, paramagnetic and dimerize. Simple, NO, because of the odd electron. Which one does not have POP linkage? Phosphoric, polymetaphosphoric, hypophosphoric. Yes, students? Yes, hypophosphoric. That's the answer. You write the structure and check. Which acid is strongest acid? Perchloric or H2SO4? Perchloric is the answer. Easy. Next question, students. Spontaneous combustion of which one is technically used in Ohm's signal? Just now we have used this question. Almost similar, but options are different. Phosphine. The acid which contains bond having strong reducing properties, whether POH or pH. See, strong reducing property, something which donates the hydrogen. So pH. Which one is not responsible for ozone layer depletion? NO2. Chlorofluorocarbons and NO, they deplete. Next comes 34. Which statement is incorrect about white phosphorus? P4 has 6 pp single bonds, 4 phosphorus single bonds, 4 lone pair of electrons, and the bond angle is 6. Okay, right. What is the correct answer, students? Basically, when I have to see this, incorrect statement is 4 phosphorus single bonds, because when you check the phosphorus, how it is arranged, you get just. Next, students, 35th question. The number of POP bonds in cyclic trimetaphosphoric acid. Yes, simple. 3. The gases produced in the thermal decomposition reaction of lead nitrate and ammonium nitrate are. Yes. Can anybody tell me? Yes, students? Okay. I'll give you this particular thing to give me a clue. I'll just small thing. I'll give you an idea, students. N2O, NO or N2O. Try once. Try this reaction. Try by yourself. Try by yourself and tell me what is this. Then you will know. I'm just giving you a clue. What should you do? You should take lead nitrate and add ammonium nitrate. Means basically you just decompose lead nitrate and you decompose ammonium nitrate. I took one video also on this. Nitric oxide or nitrous oxide. What is that? Okay, check. Try by yourself. The O-NO bond angle is maximum in. The O-NO bond angle is maximum in which one? It's maximum in A. Remember? No? Check. It's maximum in NO3 minus. Then which of the following has the least bond angle? Right. Larger the size. Which statement is wrong for NO? Which statement is wrong? It is anhydride of nitrous acid. That's right. Its dipole moment is 0.22. That's also right. It forms dimer. Right? Yeah. Just check carefully, students. Which statement is wrong for NO? So NO, is it paramagnetic? Yes. It forms dimer. Check, students. Correct only. Because there is an odd electron. No. But important thing, NO, NO2, N2O. Don't get confused. Okay. Check carefully. Right. Okay. I'm giving this question also for you. Try by yourself and tell me. Try by yourself and tell me. Post this in the Ask It Out feature. I'll answer it. Last question, students. Which of the following hydrogen halide is most volatile? Which is most volatile? Larger the size, more volatile. Simple. So we have done 40 questions in almost 10 minutes, isn't it, students? I started explaining one question. I gave the options. So keep noting. This is the time you need to do or learn all the questions like this. Easy, isn't it, students? So the whole of inorganic chemistry is covered in this. Thank you so much for watching. And my request is, students, share it. How much ever you can, please share the video. And whatever homework I have given for 2 questions, try to solve it and send it through the Ask It Out app. Send your answer to that. And I request you to join me on the Telegram channel. Telegram channel link also is given in the description. Note it. Thank you so much, students. I'll meet you again with one more video. Stay connected. Bye-bye.